So now let's go ahead and take a look at a more realistic PPF. So remember that in the previous PPFs that we've taken a look at, those were all linear, which tells us that our opportunity costs are going to be constant no matter what. So anytime you see a linear PPF, you know that the opportunity costs are constant or are never going to change. They're going to have the same ratio. And the reason why they have the same ratio is because we assume that all of our factors of production were substitutable for one another. However, this isn't going to be the case realistically, so let's go ahead and assume that away. So no longer can land, labor, physical capital, and technology, can they be substituted for one another? It really doesn't make sense to say, hey, we need one more unit of labor, but instead of using labor, let's go ahead and use a piece of land. So just to add a little bit more realism, to add a little bit more complexity to our model, we're going to go ahead and assume that this cannot be true anymore. So as you can see right here, in most cases, land, labor, and capital cannot be easily shifted from producing one good to another. So no longer are we going to assume that they are substitutable for one another. So land does not equal labor, labor does not equal physical capital, and then so on. And when we do so, when we assume this, when we assume that these factors of production can no longer be substitutable for one another, we're going to have an increasing opportunity cost. No longer are they going to be constant or remaining the same. This is also going to inherently change what our PPF looks like as well. So as you can see right here, our PPF is no longer linear, it is now curved. It bows outwards in this instance. So it's going to be concave, a concave line, as you can see from this. So anytime we have a curved PPF, we immediately know that we're going to have increasing opportunity cost, and this is going to be a much more realistic PPF compared to the linear line. But the same things that we talked about in terms of the linear PPF are also going to hold true with our curved PPF in this instance as well. So here we have two goods, we have backpacks, we have tablets, we have combinations of both of these goods that the country can be producing. We can have anywhere on this red line right here. Remember, we are being production efficient if we're on this red line, but we may or may not be allocatively efficient depending on the taste and preferences of the citizens of the country. And we can also go ahead and say, hey, anywhere into the left of the PPF, this is going to be attainable but inefficient, and anywhere to the right of the PPF, that's unattainable for our current amount of resources. So a lot of the things that we've already talked about still hold true in this instance as well. And we can also go ahead and find the opportunity cost of a backpack. We can also find the opportunity cost of a tablet, the same thing that we did. And this is where our formula or our equation becomes a little bit more handy. The only difference here is, number one is now we're going to have to specify where we're initially starting from to where we are ending. So here, if we want to find the opportunity cost of a tablet, I need to tell you whether we're going from A to B, B to C, C to D, A to C, A to D, or any combination in between. And this is going to have to be true because our opportunity costs are going to be different depending on where we're starting and where we're ending. We didn't have this issue when we had a linear PPF. And then secondly, of course, we can find the opportunity cost of both of these goods. So if we want to find the opportunity cost of a tablet, we just go from left to right. If we want to find the opportunity cost of a backpack, we go the opposite direction. We go from right to left. So we'll take a look at both of these instances. So I'll go ahead and just be a little bit brief in the calculation for the opportunity cost here, and then I'll leave the rest of the sort of numbers here for you guys to do on your own as an exercise, just to make sure that you get the practice on your own with these opportunity costs. So let's go ahead and find the opportunity cost of a tablet first as we go from point A to point B. So here, let's find the opportunity cost of a tablet. And once again, because we have a curved PPF, we want to specify from point A to point B. So as we go from point A to point B, what are we gaining? What are we losing out on? So at point A, we have 12,000 backpacks and 0 tablets. And at point B, we have 10,000 backpacks and 3,200 tablets. As we go from point A to point B, we want to go ahead and use our equation. So what do we want to find the opportunity cost of? We want to find the opportunity cost of a tablet. So we immediately know that tablets should be going in the denominator right here. So it's always good for us to see exactly what we are trying to find the opportunity cost of. It goes in the denominator. Remember that opportunity costs are always going to be set in terms of the other good, so we put the backpacks on top. So opportunity cost of tablet, immediately throw backpacks on top, the other good on the numerator, and keep the same good, the tablets, on the bottom in the denominator. You want to stay consistent with this calculation, with this formula. And then you go ahead and insert the rest of the numbers that you know. So how many tablets did we gain as we went from point A to point B? As you went from point A to point B, you gained 3,200 tablets. You went from 0 tablets to 3,200 tablets. So you can go ahead and insert that number in, 3,200. On the other hand, how many backpacks did we give up on the production of as we went from point A to point B? We had 12,000 backpacks. Now we only have 10,000 backpacks. So the difference between these two numbers, we give up on the production of 2,000 backpacks. 2,000 backpacks. And then there you go. This is exactly how you calculate out the opportunity cost. Last thing that we want to go ahead and do is try to simplify this as much as possible. So go ahead, pull out your calculator, and once you simplify this, you're going to get 0.625. 0.625, and we want to keep the numerator and the denominator consistent. This is going to be backpacks per tablet. Backpacks per tablet. So this is essentially the opportunity cost of us producing one additional tablet. We have to give up on the production of 0.625 backpacks. And this is exactly the interpretation of the opportunity cost. We're normalizing the tablet down to what? In order for us to produce one additional tablet, we give up on the production of 0.625 backpacks as we go from point A to point B. And you go ahead and do the same exact steps. You follow the formula as you go from point B to C and then C to D. So as we go from point B to C, how many backpacks are we giving up on the production of? 4,000, which is why that's the numerator there. How many tablets do we gain? We went from 3,200 to 5,200, so that's 2,000. And the opportunity cost from B to C is now 2. In order for us to produce one additional tablet, we give up on the production of 2 backpacks now. So here we're noticing that opportunity cost is no longer constant, but it's actually increasing. And it's going to keep on increasing until we hit the other axes. As we go from point C to D, how many backpacks do we give up on the production of? 6,000. That goes in the numerator. How many tablets do we gain? We gain 800. That goes in the denominator. We simplify this down, 7.5. In order for us to produce one additional tablet, we now give up on the production of 7.5 backpacks. So here we have increasing opportunity cost as we go from point A to B, B to C, C to D. So this is exactly why we need to specify which points we're coming from and going to, because the opportunity costs are all going to be different. They're no longer constant. Keeping the scenario in mind, let's go ahead and find the opportunity cost of a backpack instead. So here we can obviously go the opposite way as well. We use the same methodology, just going in the opposite direction. So opportunity cost of a backpack. And let's go ahead and do it from point D going to point C. So if you want to find the opportunity cost of a backpack, using the formula that we have right here, what do we do? So what good goes on top, what good goes immediately in the bottom? So good. So backpacks are going to be in the denominator right here because that's a good that we're taking a look at. So backpacks go in the denominator. And remember, opportunity costs are set in terms of the other good. You immediately throw the other good on top. So tablet on top right here. Remember, get a lot of practice being consistent with this formula. And then you go ahead, fill in the numbers that you notice. So how many tablets are we giving up on the production of, and how many backpacks are we gaining as we go from D to C? As we go from D to C, we're gaining 6,000 backpacks. We're giving up on the production of 800 tablets. So go ahead, put those numbers in. We give up on 800 tablets. We gain 6,000 backpacks. And then once again, you go ahead and simplify this, 0.1333 tablets per backpack. Tablets per backpack. And once again, what is the interpretation of this number right here? It tells us that in order for us to produce one additional backpack, we have to give up on the production of 0.1333 tablets. So interpretation also very, very important. And as you go further throughout the rest of the PPF, as you go from C to B, B to A, using the numbers that you have right here in order to calculate the opportunity cost of a backpack, you're going to notice that the opportunity cost is going to keep on increasing as well. So here, increasing opportunity cost is still going to be holding true in this instance, no matter if you do it for good A or for good B. I'll go ahead and leave that as an exercise for you guys to do, just to go ahead and get enough practice to make sure that you see, yes, that you do have increasing opportunity cost as you go from D to C, C to B, and then B to A. So as we can see right here, our equation is very, very handy for us. what you give up over what you gain is equal to the opportunity cost of the denominator good. And we're going to go ahead and use this once again to sort of segue us into the idea of trade and specialization. So we'll go ahead, use the opportunity cost equation. We'll take a look at the PPF of two different countries or two different people in order to see key principle number 3 a little bit more clearer and a little bit more in depth why specialization is going to be good for everybody involved.